What is machine learning? Machine learning is a type of artificial intelligence that provides the computers the ability to learn without being explicitly programmed. Now, these are some big words. Let's break it down and understand what this means. To understand machine learning, let's look at a traditional programming versus machine learning side by side. So a traditional program takes input data and it executes the logic that has been written inside it by a human being, or a set of instructions given to it by a human being. It executes those set of instructions on the input data to give you the output data. That's it. That's what all our traditional programming programs do. But machine learning is different. It takes input data. Now it starts analyzing the input data. It starts extracting the structures from the input data. And then it gives as an output a program, not data, but a program, also called the model. And to this model, you can give new input data, and the model can process that input data, which it has never seen before, and give you output data. So this is where, machine learning is a framework wherein it can start learning from input data, which is nothing but experience, and create predictive models for you. What are the 3 prerequisites of machine learning? The first prerequisite is that a pattern should exist in the data. If there is no pattern in the data, it's just random events, then there's no point of machine learning. You just can't do machine learning. You can't do anything with that data. It's just random. So a pattern existing is the first and foremost condition of machine learning. Then the mathematical model that represents that data should be unknown, because if it is known, then what's the point of machine learning? There's no point of machine learning. It's already known how the data or the series of data is behaving. That reality should be unknown for machine learning. That's the second prerequisite. The third prerequisite is there should be lots of data. If there is not a lot of data, then machine learning will not work. So these 3 conditions, a pattern existing in the data, the pattern not known to human beings as a mathematical formulation, and a lot of data representing the thing that you're trying to study. All the 3 must be true. And once this is true, you can apply machine learning. Machine learning can be organized as having 2 classes of algorithms. The first one is supervised learning. If we are training our algorithm with observations, which includes both the outcome and the input data associated with the outcome, it's called supervised learning. We have unsupervised learning as the second type of machine learning algorithm. And it is a type of learning algorithm that is used to draw inferences from the data. So we give it data without its outcome. Supervised learning can be further subdivided into regression, where the outcome is a continuous number. For example, if you're trying to predict the house price, or if you're trying to predict the price of a stock, it's a free-flowing number. The second type is classification. This is the suite of algorithms where the outcome belongs to a list of value. For example, yes or no, yes, no, maybe, or the species of a flower. Unsupervised learning can also have 2 important types of problems that it addresses: clustering and principal component analysis. Clustering is related to finding similar groups or similar entities or similar trends within a large section of the data. And principal component analysis tries to evaluate out of all the data points that are given, which are most important. Are there things in it which are not important in the data, but still there, which can be ignored, and the remaining taken for machine learning to have much more manageable and robust machine learning? Let us look at some examples of machine learning. Spam filtering that is built in our email solution uses machine learning to detect whether an email is spam or not spam. Finance industry uses machine learning to predict stock prices. And in fact, in this course, in one of our exercises, we are going to try and predict price for Google's share using Yahoo Finance data. Facebook uses machine learning for facial recognition, and it tags your photo with your name and your friend's name. Now, all the Android phone these days or iOS phone these days have voice to text feature. Well, it's powered by machine learning. The law bots in US, they have basically analyzed all the legal dispositions that have been given thus far, and that after doing massive NLP is all organized, and you can go and start doing legal queries, and it's going to start advising you like a lawyer. Autonomous cars, that's the future. In probably 10 to 20 years from now, we won't be driving our car, and a lot of work is going on using machine learning in building these cars. Let's do a quick quiz to check how much we have understood the differences between regression and classification. So email spam filter, is it a regression or a classification problem? It's a classification problem because the outcome is spam or not spam. It's a list of value, so it becomes classification. Stock price of a company in the future, if you want to predict that, is it a regression or a classification problem? It's a regression problem because we're trying to predict the price. It's a free-flowing number of value. It can be one of the any infinite values. So it's regression. Let's say we want to predict the price of a house based on different input features. What kind of classification or regression would it be? Yes, it's a regression problem because again, the price of the house will be a free-flowing number. Let's say if you want to know whether the person is diabetic or not based on the blood report, will it be a regression problem or a classification problem? That's right, it's going to be classification because the outcome is yes diabetic or no diabetic. It's one of these two values. It belongs to a list of value, the outcome. So it's a classification problem. Let us look at the applications of machine learning. Now, social media, it's a star example of machine learning. There's a lot of data being generated in terms of tweets, posts, pictures, likes, dislikes, thumbs up, thumbs down, what have you, and all these can be effectively used to create segments or group of people or making predictions. What are you going to like? What are you going to dislike? Search engines, they use a lot of machine learning to figure out, to give you auto suggestions, to give you relevant searches. It kind of feels sometimes that it's reading your mind. Healthcare, there is a lot of data that gets generated around a patient in terms of what are the procedures that is being performed on this patient, what are the diagnoses that has been done on this patient by the doctor or hospital. And then that all can be used to do predictive analytics for preventive care or to predict the cost of healthcare. Banking and finance use it every day to detect your credit score or determine whether you are credit worthy of giving a loan or not, or it
it uses machine learning to detect if this transaction is a fraudulent transaction or a regular transaction. Legal services, they use machine learning extensively now to do quick ballpark checks on what is going to happen given this situation. Retail, big companies like Amazon, Walmart, Home Depot, and online e-commerce sites, they use machine learning to segment their users. It's clustering behind the scenes to figure out which kind of users exist, which kind of users would buy what products. If you buy this product, what are the other kind of products you might be interested in? Public services, interestingly, in US have started using machine learning. I was recently reading an article where a fire department has started using machine learning in some counties to detect, given a distress call, should we take the patient to the hospital or just an ambulance would do and a first aid would suffice. Security uses machine learning effectively these days to detect whether these are regular transactions in your network or these are some fishy or anomalous transactions. Should we single it out and alert the staff to start reviewing these anomalous transactions? So all the data, all these data that is being produced by these different systems, it's being analyzed by machine learning algorithms to convert it into information. And once you convert data to information, what can you do? You can provide better digital services. You can create better data products for your users. And last but not the least, you are entering into the age of information-driven applications, wherein you use data to decide how do we enhance our system, which route or way should I take my application. It's no longer a guessing game. Let us look how LinkedIn uses machine learning to do or provide better services to its customers and to its users. So LinkedIn knows your designation in the company where you're working for. It knows the location where you're working. It knows how many followers you have. The higher the followers, the more important the person you are. It knows your level of education. It knows the kind of posts you're reading, liking, or following. So using all this information or data points, it's able to apply machine learning algorithms to create, kind of better digital services for its customers. It's able to let its advertising customers know what kind of advertisements or material you should show to this profile so as to get maximum match or a better click ratio. It also uses these data points to give the users a better product. It is able to tell you, okay, you might want to be friends with this person, or you probably know this person, or you might want to follow this person, or you might want to read this post. They all eventually add better user experience. So this is how LinkedIn is using machine learning. Let's see how Google search uses machine learning. Let's say you are doing your search and you enter your search keyword. Google gives you suggestions that can be used to autocomplete your search. Now, this is done by machine learning. Some of the important factors being considered here is what is the popularity of the query? What is the geolocation from where you are doing the query? Maybe the location is important. Maybe you're searching for a place to eat, so maybe it starts showing up places nearby. Or if you're your query, how well it matches to the relevant keywords on the web. So using all these parameters, it's able to build, and much more, it's able to build possible suggestions for you, and it feels like Google is trying to read your mind. And sometimes it does make mistakes, and for those situations, it uses your power, your analysis to further enhance its machine learning by allowing you to provide feedback that these suggestions doesn't make sense in my context. Google is very smart. When it puts all of these together from millions and billions of people around the world, it becomes a very powerful auto suggestion machine. Here are some interesting facts about the job market. US is expected to have a shortage of around 200,000 data analytics professionals by 2020. It is going to create a huge opportunity for data analysts and professionals around that expertise. As per NASSCOM, big data analytics in India is expected to witness 8-fold growth by 2025. It's going to go from a $2 billion market to $16 billion. Since 2014, there has been a 200% year-on-year increase in data scientists' job searches and a 50% year-on-year increase in job listings globally on data science and machine learning. Why should we use Python as a programming language for machine learning? First, it's an open source programming language. It's freely available. Whatever code or program you write in Python is your intellectual property. Second, it's quick and easy to install, and it takes only minutes to write your first program after installation. Third, it has a very simple syntax. You can write programs in very few lines that in other languages you have to write many more lines. So in the top half, I have 5 lines of Java code that prints hello world on the console. The same thing in Python can be done in 1 line. So Python is a very succinct, compressed language, and it has been designed to do data munging, data analysis, and data transformation, which are ideal for machine learning. The fourth reason to use Python as your programming language is because it has a lot of out-of-the-box libraries that has been designed for data analysis. And the top 4, if you ask me, are Pandas. It's also called Excel on steroids. SciKit-Learn, which implements all of your supervised and unsupervised machine learning algorithms. NumPy, it's the library that implements managing your n-dimensional data in a very optimized and high speed, very optimized suite of algorithms for your multi-dimensional data. And Matplotlib is your charting and plotting library that will help you do amazing visualizations on your data. The fifth reason to use Python is it's one of the top 10 programming languages of the world. If you go to any job site or any website or any blog site, and if you search what is the top programming language, Python will make it to the top 3 most of the time. The sixth and the final reason why we should use Python is because it is loved by data scientists. It is in fact becoming the default programming language used by data scientists. What is this course all about? This course will take you from zero to machine learning hero in 42 days. This course will teach you all the basics and advanced features of Python that is needed for machine learning. And then it's going to teach you machine learning in detail and how to use the different out-of-the-box libraries built on top of Python to do machine learning. This course is split up in 2 modules. The module 1 is about Python relevant for machine learning, and module 2 is dedicated to machine learning using Python. In the first module, we will learn Python basics, the native data types in Python, how the flow control works in Python, how you write functions, the user-defined functions and the in-place lambda functions. How do you do file handling, that is read a lot of data from the files or write data to the files for the purposes of machine learning. We'll learn how to use matplotlib for doing your charts. You learn NumPy to handle two-dimensional arrays. You learn Pandas library that's built on top of NumPy to read data out of the internet or from files and create nice indexes and columnar data out of them. And you will learn SciKit-Learn. That is where the core machine learning algorithms are implemented. And in the machine learning, you will learn what is machine learning. You will learn supervised learning in depth. Then we will cover unsupervised learning. You will learn different regression algorithms. You will learn the most popular classification algorithms. You will learn clustering algorithms and all about principal component analysis. You will learn how to use cross-validation to improve the accuracy of your model on actual live data. You will learn how to do pre-processing, the statistics around it, and how Scikit-Learn provides you amazing pre-processing libraries. And lastly, we will conclude the course. So let us review the training plan. In the first week, we are going to learn the basics of Python and native data types together with an introduction to the course. In week 2, we are going to learn Python flow control and Python functions. In the third week, we are going to cover file handling, matplotlib, NumPy, Pandas, and Scikit-Learn. So in the first 3 weeks, we are going to cover end-to-end Python as a programming language from scratch for machine learning. In week 4, we're going to start our machine learning journey. We're going to cover an introduction to machine learning, supervised learning, linear ridge and lasso regression. In week 5, we are going to cover logistic regression, decision trees, k-nearest neighbor classification, and data munging. In week 6, which is the final week of the training, we're going to cover unsupervised learning, principal component analysis, k-means clustering, and then we're going to conclude the course. We believe hands-on exercises as a backbone for any learning, and especially machine learning, it becomes all the more important. This course includes numerous hands-on exercises for each chapter. The exercises have been designed after extensive study of the industry requirements. The course is spread across 6 weeks to give you just the right amount of time for both the study material and also the exercises. Let us look at the requirements of this course. You will need a desktop or a laptop computer with Windows, Mac, or Linux operating system. The course will walk you through installing the necessary free softwares. Some prior coding or scripting experience is nice to have, but is not mandatory because we'll teach you coding from scratch. Basic level math skills will be required to understand certain equations that we have. You will need an internet connection to attend the instructor-led lecture and problem-solving sessions. If you can arrange a mic, it will be great as you can interact with the instructor during the weekly sessions. Who is this course for? Anyone looking to kickstart their career in data science and machine learning is an awesome fit for this course. The developers and testers who are looking to change their career will find this course very useful. Are analysts looking to enhance their machine learning skills by switching to Python as a programming language would love this course. And last but not the least, the BI professionals who want to learn machine learning using Python, this is the course for them. After this course, you can use Python effectively as a programming language. You will be able to use Python to perform machine learning. You will understand the overview of machine learning. You will know in depth the differences between supervised and unsupervised machine learning. You will understand the differences between regression, classification, and clustering. You will use Python to effectively process data and build machine learning models. You will be able to use cross-validation to tune the accuracy of your model. And lastly, you will lay the foundation for learning Spark from Apache. This course will teach you linear and polynomial regression in depth. It will teach you where it works and where it doesn't work. And in the situations where it doesn't work, how ridge regression can be used to deliver superior models. And it will teach you where ridge is working more effectively as opposed to linear and polynomial regression, and what are the pitfalls of ridge regressions, and how a lasso regression can further be used to create a simpler, more interpretable model, and yet that delivers good accuracy in certain situations. You will learn how a sigmoid function and a logit function can be used to start doing binary classification with a regression-like model. This is also called logistic regression. You will also understand what is a decision tree. How does it work? How is entropy and information gain used to build an effective decision tree? You will build decision tree models in Python using the out-of-the-box SciKit-Learn libraries. You will learn what is a k-nearest neighbor classifier. How does it work? What is the theory behind it? And you can effectively create your KNN model using just 2 lines in Python. You will learn and understand how to do principal component analysis and use its power to reduce unwanted dimensions of features from your data. This will help you simplify your machine learning data and let you build more effective machine learning models. You will also learn the theory behind clustering and how k-means clustering works. You will write your Python code to build k-means models and run it on real-life data to start doing your clustering. We will teach you how to use matplotlib to plot amazing charts like these or these to understand your data and help you do effective machine learning. We will teach you how to use JUPYTER to write your Python programs from within the browser and share your code on GitHub or any other popular coding site. In this course, you will learn to predict the per capita growth of a country. Predict the price of, let's say, Google share using data from Yahoo Finance. You will learn how to predict house prices in Boston City. You will learn how to predict the species of iris flower. You will learn how to predict the population growth of a country. You will learn how to use different models to predict the presence of gold in India. And we'll do much more fun assignments. And last but not the least, we will teach you Python from scratch. You can visit our website mcalglobal.com to review the amazing testimonials we have got over the time. Next steps. Email us at ml@mcal.in to get details on our upcoming batches. We would love to hear from you. Thank you for viewing our webinar. Wish you all the best in your learning journey. And don't forget to email us at ml@mcal.in.